going to take a look at another quadratic word problem. This one is a little bit different. It says the TAB hockey team is fundraising by selling cupcakes. They know that they can sell 40 cupcakes if they charge $2 each. If they raise the price by 25 cents, they will sell 2 fewer cupcakes. What price should they charge to bring in a revenue of $96? So right now, if they sell 40 cupcakes for $2 each, 40 times 2 is $80, which means that sometimes raising and lowering the price can actually earn you more money. And it's a delicate balance between how many less you're going to sell and how much more you're going to charge. So these questions are a little bit different from some of the other ones that we've done. I like to make a table to set this up, but when I read the sentence and I try to figure out what to let my let statements be, I see what price should they charge to bring in a revenue of $96. So normally I would let X be the price, but in this case I'm actually going to let X be something different. In this question, they're changing the price of their cupcakes, and we don't know whether they're going to raise the price once or twice or 3 times or 4 times. We're trying to figure out what the best thing to do is. So I'm actually going to let X be the number of times that they raise their price by 25 cents. So I let X be the number of times they raise the price, and they are doing it by 25 cents each time. I just didn't want to write all that out. So there are many different ways to set up this question. What I like to do is start by making a table where I look at how much they're charging and how many they can sell. So I'm going to make a little bit of a table here that has the number sold and the price. And I'm going to look at 2 different things. I'm going to look at what they can do now and what they're planning on doing to change it. So I'm going to say original and the change. So they know that they can sell 40 cupcakes if they sell them at $2 each, right? So the original number sold would be 40 and the price would be $2 a cupcake. Now they want to raise the price by 25 cents. So I'm going to put under the change that we're going to add on another 25 cents. But I don't know how many times they're going to do that. They might do it once, they might do it twice, they might do it 3 times. I'm not sure what the best balance is for this. So what I do know is that I let X be the number of times they raise the price. So if they're raising the price by 25 cents every time, we're going to actually do 25 cents times X, so that if we're raising the price once, we do 25 cents times 1, which is 25 cents. If they raise the price twice, we do 25 cents times 2, which is 50 cents. If they raise it 3 times, we do 25 cents times 3, which is 75 cents. Now, for the number sold, if they raise the price, they sell 2 fewer cupcakes, which is less. So we're going to subtract 2 every time they change the price. And it is happening more than once, so we're going to do 2 times X, so that if I'm changing the price 5 times, 2 times 5 means they're going to sell 10 less cupcakes, which means that the number that they sell is going to be 40 minus 2X, and our price is going to be $2 plus 25 cents for every time we lower that price. Now, revenue is the number sold times the price that you sell it at. In the question, it says we have a revenue of $96. So I'm going to put that in for the revenue. The number sold starts at 40. We're going down by 2 every time, so 40 minus 2X. And the price that we're selling it at is $2. And we're adding an additional 25 cents every time. So from here, what I have is I have a quadratic, and I'd like to solve it. So it would help if I could write it in a form I'm a little more used to seeing, which is standard form. So I want to multiply all this out, collect up all my like terms, and move everything over to one side. So I'm going to leave the 96 where it is for right now, and I'm going to multiply out these two brackets. So 40 times 2 is 80. 40 times 0.25 is 10x. Negative 2 times 2 is negative 4x. And then negative 2 times 0.25, x is negative 0.50 or negative 0.5 x squared. If I collect up my like terms, 10 and 4, that's going to make 6. Minus 0.5x squared. Now I need to move all of the terms over to one side, and I have a choice. I could bring the 96 over here, or I could take all of these terms over there. And the one with the x squared is negative. So I tend to, when the x squared is negative, I tend to bring the terms over to the side that would make it positive, but it's up to you. It works either way. So I'm actually going to move these ones over to this side. So this is going to become positive 0.5x squared. That positive 6 is going to become a negative 6x. And then I've got the 96. We're going to take away 80. And 96 take away 80 is 16. So I have 0.5x squared minus 6x plus 16 equals 0. Now, you have a choice at this point. I see that it's equal to 0, and I want to solve. So I can solve by factoring, or I can solve by the quadratic formula. Our last question we solved by factoring, so I think I'd like to do this one by quadratic formula just for practice. So the quadratic formula, I'm going to list my A, B, and C. So A is always the number in front of the x squared, so that's 0.5. The B is the number in front of the x, which is negative 6. And the C is the number that doesn't have an x, which is the 16. And then I always like to write down the formula. So I have x equals negative b plus or minus square root b squared minus 4ac all over 2a. So negative b, I have negative 6. Negative, negative 6. It really just means we're changing the sign. So a negative negative does make a positive 6 plus or minus negative 6 squared. And it's a good idea to put those brackets in. It'll help you with your calculator. Minus 4 times a, which is 0.5, times c, which is 16, all divided by 2 times 0.5. Now, I'm going to work out what's under the square root. Negative 6 squared, I know, is going to be 36. Okay. So, negative 6 squared, actually it's a good idea to put it in brackets. Doesn't matter on my calculator, but it might on yours. So negative 6 squared minus 4 times 0.5 times 16 leaves me with 4. And 2 times 0.5 is 1. So I could do 6 plus or minus the square root of 4 on my calculator, but I know that the square root of 4 is 2. And really dividing by 1 isn't going to make that much of a difference there. It's just going to be whatever the number is on the top. So we're going to split it up into the adding. We're going to do 6 plus 2 over 1. So 6 plus 2 is 8. Divided by 1 is 8. And if I subtract, 6 take away 2 is 4. Divided by 1 is 4. So I get 4. So x equals 8 or x equals 4. Now, what did we let x be in this question? I like to go back up and check my let statement. We let x be the number of times they were going to raise the price. So what this means is they are either going to raise the price 8 times, or they're going to raise the price 4 times. Now, if they raised the price 8 times, and I wanted to know what the price was, go back up here. We said our price is $2 plus 25 cents times the number of price changes. So it's going to be $2 plus 25 cents times 8. So 25 cents times 8, that's another $2, which means they're going to charge $4 per cupcake. That's pretty pricey. Well, if we try the next one, I get 2 plus 25 cents times 4. So that's going to be 2 plus 1, which is $3 per cupcake. Now, it didn't ask me for this, but I'm going to do it anyways. I'm going to check out the number sold. The number sold was 40, take away 2x. So 40, take away 2 times, in this case, 8. 2 times 8 is 16. And 40 take away 16 is 24, which means they could sell 24 cupcakes at $4 each. And I'm just going to check. 24 cupcakes times $4 each gives me that $96 I was looking for, so that's good. And then here, if we only change the price 4 times, we do 40 minus 2 times 4. So that's 40 take away 8, which is 32. So they'd have to sell 32 cupcakes at $3 each, which also gives me 96, which means I actually have 2 possible answers here. They could either charge $4 and sell 24 cupcakes, or they could have the price at $3 and sell 32 cupcakes. So I'm going to say they should sell 24 cupcakes for $4 each, or 32 cupcakes for $3 each. There we go.